5.3 Other algebraic functions. For example, y equals square root of x. This is the square root function and the graph looks like this, only in the first quadrant. Now, the fourth root of x looks very similar. It's still in the first quadrant only, but it's a little bit more rounded like this, but very similar. Now, if you have the cube root, which takes all real numbers, then the graph is in the first and the third quadrant. Now, properties of radicals. Properties of radicals. X and y are real numbers. They belong to the real number system. M and n are natural numbers, meaning 1, 2, 3, 4. So we have a product rule that says nth root, meaning square root, cube root, and so on, of xy is nth root of x times nth root of y. Power rule. If I have nth root of x to the m, that is equal to nth root of x, all that to a power m. Quotient rule. If I have nth root of x over y, I can break this down nth root of x over nth root of y. Now, if n is odd, then nth root of x to the n is equal to x. That means if n is 3, 5, 7, and so on. If n is even, that means square root, fourth root, and so on, nth root of x to the n has to be absolute value of x because the square root and the even root take only positive numbers under the radicals. Another formula, x to the power 1 over nth, fractional exponent, is actually nth root of x. And x to a power m over n is actually nth root of x to the n. So now graphing. Example, sketch g of x equals cube root of x minus 1 minus 2. So what is the parent function first? The parent function is y equals cube root of x. So cube root of x, we already know what the graph looks like. We had right here. And then decide on the transformation. So we have 1 unit to the right, 1 to the right, and 2 down. So we have the parent function that looks like this. Y equals cube root of x. And that same function we're going to transport 1 to the right and 2 down. So 1 to the right and 2 down, so it's going to start here. Very similar shape like that. Label it cube root x minus 1 minus 2. Another example, g of x equals negative 2 cube root of x plus 1 plus 4. Again, we have parent function, which is the most basic function from that family, cube root of x. We're going to do 1 unit to the left, 4 up, and it's going to be reflected upside down or reflected with respect to the x-axis. And And of course, the 2 will change the curve a little bit, but not much. So here is the parent function, cube root of x. And we're going to do 1 to the left right here and 4 up. Too far. So I'm going to choose a different scale so I can fit everything. So let's say this is 1, 1, 2, 3, 4. So right here. And so we also going to flip it. So if you have the reflection, then it's going to be like, if we're going to flip it, then that's going to be up like this and this one like that. So here you go. This is our function, -2 cube root x plus 1 plus 4. You can also make a table to help you with the values here. So you can say x is -1 or -2 or 0 and so on to get more accurate graph. Now equations, algebraic equations that we can solve. A, x plus 1 equals square root of 3x plus 7. So this is a radical equation. To get rid of the square root, which is by itself, it's a good thing, we're going to square both sides. Square both sides. And we're going to have x plus 1 squared equals square root of 3x plus 7 squared, and that's how we get rid of the square root. Now we're going to FOIL here, get rid of the square root, and 3x plus 7. Put everything on one side, so minus x minus 6, and factor. So we're going to have x and x, and which two numbers here? 2 and 3, and 3 is negative, like that. So x plus 2 is 0, and x minus 3 is 0. X is -2, and x is 3. But we must check. So check x equals -2 if it works. And you're going to have -1. Well, if we check it, it's going to be -2 plus 1. Does that equal to square root of 3 times -2 plus 7? So we have a problem that this is equal to -1. And so we know this is not possible for a square root to equal to a negative number. So we're going to reject this solution. And so only x equals 3 is our solution. Another example, to solve x to the power 2/3 equals to 4. So what we can do here, I'm going to copy it again, is to take both sides to a power reciprocal to the one we have, to 2/3. And that is power 3/2. So now these exponents, when you multiply them, they cancel. So it's just x equals to 4 to a power 3/2. I'm going to write 4 as 2 squared to a power 3/2 and cancel this. So we have 2 to the 3rd, which is equal to 8. Also, plus minus 8 would work as well. So plus minus 8. See? X plus square root of 3x plus 10 equals to -2. Now the radical has to be by itself, so we're going to subtract x, and we have square root of 3x plus 10 equals -2 minus x. We're going to square both sides. So that's the only way to get rid of the square root. So it's going to be 3x plus 10 equals, now there's a negative sign, negative when you square it. I can just write down this is 2 plus x squared, because if I factor the -1 and square it, it's going to be positive. So we don't need to worry about those negative signs. So 4 plus 4x plus x squared. Put everything on one side. So x squared plus 4x plus 4 minus 3x minus 10 equals 0. X squared plus x minus 6 equals to 0. Factor x and x, 2 and 3, but x is negative. So x equals 2 and x equals negative 3. Again, we have to check. So check x equals 2. You check in the original problem, and you have 2 plus square root of 3 times 2 is 16 equals negative 2. Not possible. Not possible. Doesn't work because square root of 16 is 4 plus 2. That doesn't equal to negative 2. So we need to reject this one and then check the other one. It should work. And this concludes the lecture for 5.3.